Hello, and welcome to Mr. Ambrose's video for the solution to example number 2 from the gift that was handed out in class today. So in example number 2 here, you are given that cosine of theta is equal to 3 over 5, and you have to perform the following. So for part A, you are told to first sketch a right triangle. So perhaps I'll just sketch a right triangle right over here. Not the best right triangle, but it'll do. We're told to place the angle theta in one of the acute angle locations. So the acute angles would be either up here or down here. You have the freedom to choose whichever one you want, but I'm going to put the angle theta down here. And then the last part is to label the size of the triangle using the value of cosine theta is equal to 3 over 5. So we're dealing here with the right triangle, and remember with trig, the acronym SOHCAHTOA still holds true. And because we are told that we have the cosine of theta is equal to 3 over 5, the ka, right, can be used to perhaps label sides of our right triangle, because cosine is supposed to be the adjacent side over the hypotenuse. So the adjacent side to this angle theta is right over here, so I can label that side as 3, and then the hypotenuse I can label as having side length of 5. And so there we have our right triangle labeled with the two sides that we know from the trig value of cosine theta. All right, part B tells us to use the Pythagorean identity to solve for the missing third side of our triangle. So that missing third side, right, is this leg over here. And Pythagorean identity, in particular here, we could just use that one leg squared plus the other leg squared equals the hypotenuse squared. So I'll perhaps write 3 squared plus x squared is equal to the hypotenuse squared. And I'm sure you guys could solve for x in that particular equation. And if you do that, we'll get the x value of 4. So we know that this leg over here has side length of 4. All right, so then part C asks for us to use the right triangle to find the other 5 trigonometric functions of theta. So we're going to be based from this particular angle, and we're going to have to solve for sine, tangent, cosecant, secant, and cotangent of the angle theta. To evaluate all of those. So we already have cosine of theta, and perhaps it would make most sense to calculate sine and tangent first, because those are what you're more familiar with. So sine of theta, using SOHCAHTOA, we know should be the opposite side over the hypotenuse. So the opposite side from theta is 4, and we can write, therefore, the sine of theta is 4 over hypotenuse of 5. All right, next we'll perhaps calculate the tangent of theta. Tangent of theta using SOHCAHTOA should be equal to opposite side over the adjacent side from the angle theta. So opposite side being 4, adjacent side being 3. That makes tangent of theta equal to just 4 over 3. Now that we've calculated sine and tangent, and we already know cosine of theta, that should make our reciprocal trig functions easy to pretty much calculate, because again, they're just the reciprocal of sine, cosine, and tangent respectively. So cosecant of theta we know is the reciprocal of sine, and since sine is given as, or we know as 4 over 5, then the cosecant of theta should be 5 over 4. In a similar fashion, the cotangent of theta, right, that's just the reciprocal, or should be the reciprocal of tangent of theta. Since tangent of theta is 4 over 3, that means that cotangent of theta should be the reciprocal 3 over 4. And then lastly, we could perhaps calculate the secant of theta. secant of theta should be the reciprocal of cosine of theta. And since cosine of theta was given as 3 over 5, the reciprocal of that is 5 over 3, and that should be the value of secant of theta. So hopefully this was helpful, and again, I hope that you're moving along with this particular worksheet. Take care.